Okay, let's start today's lecture, and it is related to the projection of a vector on a line. Projection of a vector on a line. On a line. How we are going to define all this? So how we are going to define this projection of a vector on a line? Suppose that we have a vector AB. We have a vector. This is our vector A to B, and let's call it vector A. Okay. Let us have some line, directed line segment. Let's call it L. This is your directed line. Directed line. Okay, this is our vector. Let's suppose that this vector makes angle theta in anti-clockwise sense with L. Okay, then how we are going to define the projection of AB? Projection just means you just put a torch on the top of this vector. Let us suppose here it is a torch. यहाँ पे हमने कोई टॉर्च रखी है, ये हमारी टॉर्च है. यहाँ पे जब हम टॉर्च रखेंगे, हम लाइट ऑन करेंगे तो यहाँ पे इसकी लाइट पड़ेगी. तो दैट मीन्स प्रोजेक्शन इज जस्ट द शेडो ऑफ दिस वेक्टर ए बी. यानी कि अगर आप यहाँ पे टॉर्च रखेंगे तो लाइट कहाँ पे पड़ेगी? यहाँ पे पड़ेगी. तो लेट्स सपोज कि यहाँ से यहाँ तक जो वेक्टर, जो इसकी शेडो बन गई है, वो यहाँ से यहाँ तक है. लेट्स कॉल इट वेक्टर पी. तो वेक्टर पी इज जस्ट, इट इज जस्ट द शेडो ऑफ वेक्टर ए. ठीक है. तो प्रोजेक्शन ऑफ वेक्टर ए बी और वेक्टर ए ऑन दिस लाइन इज जस्ट द शेडो ऑफ दिस वेक्टर. ठीक है. एंड लेट अस सपोज कि जो इसने यहाँ पे शेडो बनाई है वो है वेक्टर पी. ठीक है. तो याद ये रखना है कि हमें पता है कि अगर ये वेक्टर p है, ये वेक्टर a है, तो हमें पता है कि डॉट प्रोडक्ट ऑफ दीज टू a डॉट p जो आएगा वो आएगा मॉड p इंटू cos थीटा, which implies cos theta is equal to this dot product divided by magnitude of a, magnitude of p. Call it first. Okay. Now since we are in this right angle triangle, let's call it M. Let's call this point M, the top of this vector AM. So what is the magnitude of AM? How we are going to find it? So let's apply cos. So cos theta is equal to magnitude of p divided by magnitude of a. Okay, curly black here. Okay, which implies magnitude of p is equal to mod a cos theta. That means the magnitude of this projection means projection vector, which is the consequence of this vector. So the magnitude of this projection vector is equal to magnitude of a into cos theta. Now substitute first here. So we get magnitude of p is equal to magnitude of a, magnitude of p into magnitude of a. Cos theta is just the a dot p divided by magnitude of a, magnitude of p. Okay, and that is equal to, this will go with this, that is equal to a dot p divided by magnitude of p, and that is equal to a dot vector p divided by magnitude of p, and you can write it like this: A dot unit vector p. This unit vector will provide us the direction of the projection. That means this provides us the direction of the projection. That means it must be a unit vector in this direction. This is your unit vector p. Okay, so that means magnitude of this projection is A dot p, and we know that dot product is always a scalar, so this is called the projection. This is called the projection of vector A, and this vector p is called a projection vector on the line, directed line L. Okay, now projection, this is A dot p, and if you will be asked to find the projection of let us discuss that now. Projection of vector A on vector B. How we are going to define all this? Projection of vector A on vector B. Acha, above all, this projection could be positive or negative, depends on cos theta, because if our line segment is going to be this and our vector is this is your vector A, then projection is in this direction. That means in this case direction of projection and direction of directed line is same, because here theta is greater or equal to 0, less or equal to pi by 2. This is your first case. In second case, if this is directed line segment and this is your vector A, then direction of projection must be in opposite to directed line, because direction of directed line is in this direction, and if we are going to put a torch here, the shadow will be somewhere here. So this is in this direction, projection vector must be p, and here since theta is greater, that means theta must be greater than pi by 2 and less or equal to pi. Next case is going to be, this is your directed line L, and for example our projection vector is here, our vector is here, vector A. Okay, so in this direction projection is again negative, because if we are going to put a torch here, so its shadow is going to be somewhere here. That means your projection vector must be somewhere here. And in fourth case, if this is your directed line and this is our vector A, that means in fourth quadrant this is vector A. If we are going to put a torch here, shadow must be somewhere here, so its direction must be in the direction of this directed line. Okay, so that means in this your theta must be greater or equal to 270 and less or equal to 360, because it is in the fourth quadrant. Okay, now how we are going to define projection? How we are going to define projection of a vector A onto vector B? Okay, so projection of a vector A on vector B is just, we can define it like this: vector A into unit vector B. What is this unit vector? If this is your vector A and somehow here it is vector B, but its projection could be up to this only, so what is this? This is just here we can put a unit vector b. Unit vector b हम लगा सकते हैं क्योंकि it will give the direction of the projection. That means direction of the projection of this vector is going to be in the direction of b. ठीक है, so how we are going to write it, because direction will be provided by this unit vector, so we will just write a dot unit vector b, and this is equal to a dot, this is just equal to a dot I think there is some problem, wait a bit. Now how we are going to define projection of a vector on another vector b. So that can be defined like this, that can be defined like this. Now look here, we know that projection of this projection means scalar projection, that means magnitude, that is this thing. So we know that projection of this on this vector, on directed line L is equal to projection of A on B means what is the magnitude, what is the magnitude of this projection, what is the magnitude of this projection of this vector, that is this vector A dot unit vector P. In this case it must be some B, in this case it must be unit vector B, okay, into. Now this is just the it will provide as the magnitude of the projection of this vector on this vector, but what is the direction? Direction is just the unit vector B, okay, that is equal to A vector A dot vector B divided by magnitude of B by definition of unit vector into this. Again for this I can write vector B divided by magnitude of B, okay, and that is equal to A dot B vectors dot product of vectors divided by magnitude of B, that means magnitude of B ka whole square. Dot product with this vector. This is a scalar, this is a scalar, as a whole this is a scalar, and this is a vector. So as a whole projection of a vector on another vector is again a vector, and I have shown how it is a vector, and this is called a projection of a vector on another vector. This is just the projection, this is called the projection. Projection is always going to be the scalar. So in our questions, in the exercise, corresponding exercise, we will make use of this formula or this formula, okay. Hope you got it. Now let's come towards some questions regarding the projection, and we have exercise 10.3. we have already solved most of the questions of exercise 10.3, but there are some questions which are related to the projection. Let me show one. Question number 3. Question number 3 is asking for find the projection of vector I minus j. Let's call it vector A. Our vector A is this, and we have to find projection of this on vector I plus j. Let us call it vector B. Okay, this is just the name of the I minus, this is B is just the name of I plus j, and A is name for this I minus j. We have to find the projection of this. So what is the, how we are going to solve it? Shabash. So solution goes like this. projection of vector A on vector, this means projection of vector A on vector B is equal to A vector A dot vector B divided by magnitude of vector B, and that is equal to, this is dot product of A and B, that is I minus J dot product with I plus J whole divided by magnitude of B, that is magnitude of this, that is under root of 1 square plus 1 square, because k is 0 so 0 square, that is equal to I dot I is 1, I dot j is 0 so minus j square, that is j dot j is 1 whole divided by under root 2, and that must be 0 perhaps. Yes, projection must be 0.